To evaluate modern climate change, we rely on a consistent body of observational data. These indicators, drawn from independent scientific methods, collectively confirm that the Earth's climate is, in fact, warming. On the screen, you will see 6 graphs, each one representing a key piece of empirical evidence used to support this conclusion. Starting from the first graph, it shows the global surface temperature data from ground-based thermometers. These measurements, extending back to the late 1800s, show a clear upwards trend over the past century, with a marked acceleration since the 1970s. This increase in global temperature is one of the most direct and widely recognized indicators of climate change. The second graph presents temperature anomalies measured by satellite sensors. These records began in the late 1970s and confirmed the surface-based warming trend, particularly in the lower troposphere. Together, surface and satellite measurements provide consistent and overlapping evidence of atmospheric warming over time. The third graph shows the decline in Arctic sea ice extent. Since satellite monitoring began in 1979, sea ice coverage has decreased significantly both in area and in thickness. The Arctic is in fact warming at a faster rate than the global average, a phenomenon known as Arctic amplification. The fourth graph shows a cumulative glacier mass loss. Nearly all monitored glacier around the world, from Alaska to the Alps, has been shrinking. This is a direct response to rising temperatures and is one of the most visible manifestations of climate change. The fifth graph presents ocean heat content, measured in joules. Over 90% of the excess energy trapped by greenhouse gas is absorbed by the ocean. This graph shows a persistent rise in stored heat, particularly in the upper ocean layers. Warming oceans influence marine ecosystems, sea levels, and the intensity of tropical cyclones. The final graph shows global mean sea level over time. Since the early 20th century, sea levels have risen by over 20 centimeters, with a clear acceleration in the recent decades. This is driven by both thermal expansion of seawater and the melting of glaciers and land-based ice sheets. Rising sea levels increase flood risks, particularly for low-lying coastal regions and infrastructure. For the exam, these indicators, taken together, form a robust, multi-source evidence base for modern climate change. Each one reflects long-term trends that are consistent across disciplines and geographies. For the exam, it is important to recognize that climate change is supported by persistent measurable and converging data, not isolated weather events or short-term variability. Understanding these trends will strengthen your ability to interpret climate-related risk scenarios and answer data-driven questions with confidence.